In this video, we're going to work problems 39 through 46, and we're going to finish off this Chapter 3 exam review. So in this section, we're going to be solving systems of equations that contain three variables. So number 39 is given to us as this system, and it looks like we're actually given the value of t right here already. So this is given to us. So since we know the value of t, we're already kind of one leg up, so we can go ahead and plug that in right up here and find r, because this equation only has r and t, and we know t. Let's go ahead and do that. 6r minus t, and t is 3, equals 15. So let's add 3 to both sides. 6r equals 18, which means r is also 3. So we know that t is 3. We know that r is 3. So let's go ahead and put those into this first equation that we had. I'm going to go ahead and rewrite it over here so we have a little more room. So r equals 3s plus 5t minus 24. So r is 3. 3s, that's what we're looking for, is the s now. So plus 5t, and t is 3 minus 24. So 3 equals 3s plus 15 minus 24. And then I have some like terms I can combine right there. So it'll be 3s minus 9. When we add 9 to both sides, we'll get 12 equals 3s. So s will end up being 4. So since we have three unknown values, instead of just an ordered pair like we've seen before, now we're going to have an ordered triplet. And we're going to put them in alphabetical order, R, S, T. So 3, 4, 3. And there's my solution for number 39. In number 4, we're given this system with A's, B's, and C's. And it looks like right here we have A almost solved for already. So if we do that, 4A equals 24, we can divide each side by 4, and we get A equals 6. So that's nice because it automatically gives us one of the values. Okay, so what we can do now is go ahead and plug that A equals 6 into these other two equations. So A plus 3B, well, this will end up being 6 plus 3B minus 5C equals negative 7. And we subtract 6 from both sides, we'll get 3B minus 5C equals negative 13. Okay, we can also plug 6 into A for this equation, and we'll get 6 minus B minus 5C equals 17. Same thing, subtract 6 from both sides, we get negative B minus 5C equals 11. So we have these two equations now. Notice two equations, and they both have B and C. So it looks like we could put these together and use elimination on them. So here's what I'm going to do. I'm just going to rewrite them and stack them. So there was the first one, and here's the second one. It looks like in this case I could get rid of my C's pretty easy by just multiplying by a negative on one of these. So let's just take that by a negative right there on the top one. So I get negative 3b plus 5c equals a positive 13. And then I'll go ahead and rewrite that second equation. When I add them up, it'll be negative 4b. My c's go away, and I get 24. So if I were to divide both by negative 4, b would equal negative 6. So far I have a is 6, b is negative 6, and then we can plug these into whatever equations we want and to get the other value. So let's just go ahead and plug into this equation right there for no other reason than just that one, I don't know. So 3 times the value of b, which is negative 6, minus 5c equals negative 13. So negative 18 minus 5c equals negative 13. Okay, so when I add 18 to both sides, negative 5c equals 5. So c should be negative 1. So it's an ordered triplet again because I have three values, a, b, and c, and I'll put them in alphabetical order. So a, b, and c. So it should be 6, negative 6, negative 1. And that'll be my solution for number 40. Okay, for number 41, we're given a nice system here. So we have x's, y's, and z's, and we're trying to figure out how we can solve this. Well, in the first equation we have all of them, x, y, z. Second equation I just have x and z. The third one I just have x and y. So here's what I could do. I could add the last two up, and that would force an x, y, and z, and then I could put it with this x, y, and z. Okay, so let's go ahead and do this. So if I were to add these two equations, I would get 5x plus 2y minus 4z equals 16. And then I'll go ahead and right underneath it I'll put the other equation that had all the variables. Okay, so now I've got x, y, and z here. It looks like my y's are close to canceling out. So let's go ahead and multiply the second equation by a negative 2. So I'll rewrite the first equation. Now I'll multiply the second equation by 2, so 12x minus 2y plus 10z equals what? Positive 6? So I'll end up with a 17x, my y's go away, plus 6z equals 22. Well, that's nice because this x and z, I have another equation with x and z. So let's go ahead and stack them. Okay, it looks like I can probably get rid of the z's fairly easy because they have a least common multiple of 12. So if I multiply the top one by 2, that'll give me 12z. Multiply the bottom one by 3, that'll give me a negative 12z. So let's go ahead and do that. So 34x plus 12z equals 44. Negative 3x minus 12z equals 18. Well, my z's will cancel out. I'll have 31x, it looks like, equals 62. So if I were to divide both sides by 31, I'll get x equals 2. Okay, that's really nice because now I can plug it back into one of the equations with just an x and a z. So let's go ahead and do that. We'll say a negative x, which is negative 2, minus 4z equals 6. So if I add 2 to both sides, it'll be negative 4z equals 8, and z will be negative 2. So now that I have x and I have z, I can plug them back into any one of these equations. For that matter, let's just do the one with the 2y. So 6 times my value of x, which is 2, plus 2y equals 10. So that'll be 12 plus 2y equals 10. I'll subtract 12 from both sides, and 2y equals negative 2, so y equals negative 1. So I have my values of y here, x over here, and z way over here. So since it's an ordered triplet, since I have 3 variables, I'll put them in alphabetical order: x, y, z. And there's the answer for number 41. In problem number 42, we have again 3 variables, x, y, and z. Notice z only appears once right down here in this final equation. The first 2 equations just have x and y. So that's really nice because we could use elimination or something just on those first 2 equations. So go ahead and rewrite them. So what could I do to get rid of one of these? Well, it looks like the x's will be easy if I multiply the top one by 4. So 4x minus 24y equals negative 80. And then negative 4x plus 5y equals 4. My x's cancel, and I'm left with negative 19y equals negative 76. So y should equal a positive 4. If that's the case, I can plug it back up here, and so I have x minus 6 times y, which is a positive 4, equals negative 20. So x minus 24 equals negative 20. So I could add 24 to both sides and get x equals 4. So it looks like both x and y are 4. So with that being the case, I could use this final equation that has my z in it to go ahead and find my z. So negative 2x, and x is 4, plus 5y, and y is 4, plus 5z equals 2. So negative 8 plus 20 plus 5z equals 2. So when I go through, I can solve this fairly easily. I'll have 5z equals negative 10, and z then should be negative 2. Again, if that's the case, I can put it in alphabetical order: x, y, z. So x is 4, y is 4, z of negative 2, and there's the solution for number 42. In number 43, I'm given a system that has a, b, and c. The first equation has a equals this stuff with b, c, and a constant, and then my next equations have b and c, and then a and c. So since in the first equation I've solved for a, I'm going to go ahead and take this expression, which is a, and then go ahead and substitute it in for a of that equation right there. So when I do that, I'll have negative 2b minus 3c minus 21, which that's my a. I'll go ahead and write the rest of it down. Plus 5c equals 15. So let's go ahead and put some like terms together. So negative 2b, and then my negative 3c and positive 5c will be positive 2c. Add 21 to both sides, and that'll leave me with 36. Okay, so if that's the case, then I have b and c right here, and I have this equation here that has b and c. So I'm going to go ahead and write that down. Negative 2b plus 2c equals negative 14. So I could multiply one of these by a negative 1, so I'd have the first equation gets brought down, and then change here. And an interesting thing is going to happen. My b's all cancel, my c's all cancel to give me 0. When I add that up, I'm going to get 50. So what appears to have happened is that all my variables cancel out, and I'm left with a false statement. 0 equals 50. So when that's the case, what do we write? Well, we write no solution, because there are no values of these variables that will make this work out. So number 43 is no solution. Okay, on number 44, looks like we have R, S, and T, but S only shows up in one place, so we could take the first two equations and solve that system for R and T, and then go ahead and plug them into the third equation and solve for S. Let's go ahead and do that. So I'm going to rewrite these first two equations, and then it looks like we could probably easily solve for T by eliminating R. So let's go ahead and multiply by negative 4 down there, so we'll rewrite the first equation. And then I'll multiply through, so 4r minus 20t equals 52. Okay, so my r's go away, so I have negative 18t equals 54, so t should equal negative 3. So if I plug it back in right up here, I can solve for r. Negative r plus 5t, and t is negative 3, equals negative 13. So negative r minus 15 equals negative 13. Let's go ahead and add 15 to both sides to get that r by itself. So r should be negative 2. Okay, so basically we take that negative r equals 2, so we divided both sides by negative 1, just if you were wondering. So if r is negative 2 and t is negative 3, let's go ahead and plug those in to this final equation. So 4r, so 4 times negative 2, plus 5s plus t, which is negative 3, equals 4. So it'll be negative 8 plus 5s minus 3 equals 4. So 5s minus 11 equals 4. Let's go ahead and add 11 to both sides. So 5s equals 15. S should be 3. So, since there are 3 variables, we'll write this as an ordered triplet, and we'll put them in alphabetical order. So, R, S, T. So, R was negative 2, S was 3, T was negative 3, and the solution to number 44 is negative 2, 3, negative 3. Okay, number 45, we have r, s, and t again, and we have these three equations. Notice in the first two equations we have all three variables, and in the last equation we just have s and t. So I bet if we put the first two together and eliminated r, and we're left with just s and t, we could probably combine it with the third one. So let's go ahead and do that. Let's go ahead and take these two equations here, eliminate the r's by multiplying the top by -2, and I'll go ahead and write below that what I'm going to get. So negative 6r plus 12s minus 4t equals 14. And then the other equation just comes along for the ride. When I combine those, my r's cancel out, which was the goal. So I get 10s minus t equals -4. Now I'm going to go ahead and take this equation and write it below here. So negative 5s plus 2t equals 8. And I notice my s's, if I multiply this guy by a 2, would be helpful here. So copy down the first equation, and now distribute a 2 through the second equation. Okay, so when I have this, my s's cancel, and I'm going to have 3t equals, and 16 minus 4 is going to be 12. So t equals 4. Okay, so I can take that t equals 4 and plug it back in up here. And let's do it in the 10s minus t, so minus 4 equals -4. So if we add 4 to both sides, I'll get 10s equals 0, which will give me s equals 0. So now that I have two of my values, I have t down here and s up here, let's go ahead and plug it into one of these top ones and find r. Let's just go ahead and do it in this first one. So 3r minus 6 times s, but that was 0, plus 2 times t, which was 4, equals -7. Okay, so that goes away, and if we have that, 3r plus 8 equals -7. That'll be 3r equals -15, and r equals -5. Okay, so I got all three of them now. I have r, s, and t. So there's three of them, so I'll put it in alphabetical order and write it as an ordered triplet, r, s, and t. So the solution to number 45 is -5, 0, 4. In this final problem, number 46, I see that I have x, y, and z's that I'm looking for. So the first equation has an x and a y, and the other two equations have everything, x, y, and z. So I bet if I took these last two equations and eliminated z, I could put the x and y that's left over with the x and y in the first equation. So let's go ahead and do that. Let's go ahead and eliminate these z's. So I have a -4 and a -3, so I'll have to flip them and go 3 and 4. And then one of them will have to be negative, so let's call it -3 up there. So let's go ahead and distribute that. So it'll be a -3x minus 9y plus 12z equals -60. And then when I distribute my 4 through there, I'll get -8x plus 20y minus 12z equals, what's that going to be, 104? So my z's cancel, which is by design. So I have -11x plus, and then it looks like 11y equals, and then that should be 44. I can put that now with my 4x minus 4y equals -16 at the top. Okay, so what that looks like, I can have x's and y's. I can get rid of the x's by multiplying the top one by 4, the bottom one by 11. Let's go ahead and scoot it up and then work through this thing. So -44x plus 44y equals 4 times 44 is 176. And then the bottom will be 44x minus 44y equals -176. Well, if you see, the x's cancel, but the y's also cancel, and the 176's also cancel. So I'm left with 0 equals 0. Well, what happens when all your variables cancel and you're left with a true statement? Well, then the answer is infinite solutions. Infinite solutions, because it doesn't matter what you put in for your variables, it'll work out to infinitely many solutions. So there you go. Number 46 is infinite solutions.